In this video, we're going to look at these friction problems, and we're going to start with this problem right here. We have this crate that's being pulled by this force P, and we're told the angle is 30 degrees, the force P is 200, the crate weight is 150 pounds, coefficient of static friction is 0.3. Find the friction force under these conditions. And under these conditions, will the block move? As usual, we always want to start with a free body diagram. Let me find some blank paper here. Free body diagram of the crate. You basically have this force pushing up here. It's going to be the normal force. It's going to be the reaction. And so you have like a normal force is going to be acting on the crate, basically the floor pushing up on it. And then we have this force P over here, which is 200 pounds. And this is 30 degrees. We have a 150-pound force down here. That's the weight of it. And that's our free body diagram. The only thing we need to add is the fact that this crate is going to attempt to be pulled in this direction. There'll be a friction force that is applied in the opposite direction. So it's going to be a friction force like that. Again, remember, friction force is always going to be equal to the coefficient of friction times the normal force. So there's our free body diagram. And so now we want to find the normal force. And so what we're going to do is sum the forces in the y direction. And set that equal to 0. And we'll call up positive. And so in the y direction, we have the weight pushing downwards. So that's going to be a negative 150. And then we have the normal force reaction pushing up. And then the y component of this force is going to be also in the positive direction. It's going to be 200 sine 30 degrees, and the whole thing equal to 0. And if you put all that in your calculator, you're going to get the normal force is 50 pounds. And then so the friction force is, as we set up here, is always going to be mu times the normal force. And mu is given as 0.3. And the normal force is 50. So the friction force is going to be 15 pounds. And then to determine, so will the block move? And it will move if the horizontal force is greater than the friction force. And so let's see, find the horizontal force. And the only horizontal force we're going to have is the force from this 200 pounds. And so we'll call that F of X is going to be 200 times cosine 30 degrees, which is equal to 173.2 pounds. So in other words, what we did, we just took, this 200, we had 30 degrees here to find that this F of X here of that. And then we had found that the friction force was 15 pounds. So since the horizontal force is greater than the friction force, block will move. Next, we're going to look at this problem here. And this uniform dresser has a weight of 90 pounds, rests on tile floor, which the coefficient of friction is 0.25. If the man pushes in the direction theta 30 degrees, determine the smallest magnitude of force needed to move the dresser. Then we're done with that. The man has a weight of 150 pounds. Find the smallest static friction between his shoes and the floor so that he does not slip. So let's take a look at this problem. As usual, make a free body diagram of the dresser. And so this would be the free body diagram of the dresser. Will look something like this. The 90 pounds for the weight of the dresser, the force that the man's applying to the dresser, the normal force reaction of the floor, and the friction force is always mu times the normal force. And so let's try to start applying our equations. We're going to have to apply summation of x and summation of y. So let's do the summation of forces in the, let's do the y direction first. And so in the y direction, we have the 90 pounds downward. We have this force here also going downward, F, and this will be the sine of 30 degrees will be the y component of this force here. So it'll be F sine 30. And then the normal force pushing up, that'll be positive, and that'll all be equal to 0. And so we can then solve for this. The normal will be 90 plus 0.5 F. Again, normally we want to find the normal force first. And that's why it probably makes the most sense to sum the force in the y direction. That'll give us the normal force, even though we can't solve for it explicitly because we don't know what F is yet. But that's usually the best place to start. So now sum the forces in the x direction. And so in the x direction, we're going to have F cosine (30°). And then the only other thing in the x direction is going to be the friction force. And so this is going to give us 0.866 times F. And then, of course, the friction force, we said is going to be the coefficient of friction times the normal force. And we know that the coefficient of friction is 0.25. And then the normal force is given above is 90 plus 0.5 F equals 0. And that's what that is there. And let's work this out a little bit. And this is going to give us, 22.5. This is minus 0.125 F equals 0. And then we'll put these together. And so the force required to get the dresser start moving is going to be a force of 30.36 pounds. That's what the man has to apply to get the dresser start moving. Then the next thing we have to find out is what's the minimum static friction required to keep the man from slipping. So now we want to make a free body diagram of the man. And so gonna make it so that's supposed to be the man. I realize not a great drawing, but you can draw it more artistically if you like. So there's the man. He weighs 150 pounds, and so he's pushing on the dresser. We determine he's going to need to push with this much force on the dresser, so the dresser is going to be pushing back at him with that same amount of force. 30.36 pounds will be pushing back at him. And of course, it'll be at that same angle, 30 degrees. And again, there's going to be a normal reaction from the floor. And so now as he's pushing on the dresser is kind of pushing back at him. And so the dresser is sort of trying to push him to the left. So that means the friction force will be operating to the right. So it'll be in that direction. So those are all our forces. So once again, let's sum the forces in the y direction. To find our normal force, like I said, we usually want to find the normal force first. And so we're going to have, let's see, N will be operating upward. The 150 pounds of the man will be downward. And then we want the Y component of this, which is going to be 30.36 sine 30 degrees. Set that equal to 0. And if you put all that into your calculator, you'll get that the normal force is around 134.82 pounds is going to be the normal force. And then to find the friction required for equilibrium, again, sum the force in the x direction. So it's going to be, so again, you see our friction force is acting to the right. So it's going to be positive. And then we need the x component of this thing. So it's going to be minus 30.36 cos 30 degrees equals 0. Now for the friction force, again, we know that's always going to be mu. And again, that's what we don't know, the mu of for the man. Let me call it mu s of a man. And then that's times n, which we know from above, 134.82. And if you put this over here in your calculator, you're going to get minus 26.29. Set that equal to 0. And then when you solve for mu s of the man, that's going to give you 0.195. That's the coefficient of static friction for equilibrium, or the coefficient of static friction to keep him from slipping. Next, we'll look at this problem here. We have this 200-pound block, 140-pound force trying to move it this direction. And there's a P force here. And we'll go through the steps here. In fact, if the first thing it asks is for the normal force, and once again, let's make a free body diagram. And so we have block like this. And then we have a 140 pounds here. 35 degrees. We'll have a normal reaction here. Now for this part A, the P is going to be 0, so we won't even show the P force. And if it's trying to be pulled in to the right, that means the friction force will operate to the left. Once again, that's always going to be your mu times your normal force. So again, to find the normal force, do part A, we'll sum the forces in the y direction. And we're going to have our normal force acting upward, the 200 pounds downward. And then we want the y component is 140, which is going to be upward. It's 140 sine 35 degrees. And that's all equal to 0. That would be 119.7. That's our normal force. Then the friction force. Once again, we said that's going to be mu times the normal force. And mu is going to be 0. We said that's going to be 0.35 times our normal force is 119.7. And so it means our friction force is going to be 41.9 pounds. So now a lot of times we were solving to see what force we required to move the block. Here we already have the force applied and we want to see if it is going to move. And so to see if the block moves, see if the horizontal force is greater than the friction force. And so the horizontal force again is going to be just that f of x here, and we have our friction force opposing it. We already determined that that was 41.9. So let's see what our horizontal force is. That would be f of x is going to be equal to 140 cos 35 degrees, which is going to be 114.7 pounds. Is going to be the horizontal force. So, and that's greater. So f of x is greater than the friction force. So the block will move. So now the next question is, what's the smallest force P to cause the block to move to the left? So now, we're not going to assume P is 0 anymore. So let's take a look at that. So this is part D. We're going to have to make another free body diagram. So again, we're going to have our 200 pounds down. And we're going to have 140 pounds this way. 35 degrees this way. And then P is this direction. 20 degrees this way. And then, so now we want to see what it's going to take for P to move the block to the left. We want to see what value here. And so now, of course, if we're trying to move the block to the left, that means our friction force this time is going to act to the right. So we want to show that this way. So remember, the friction force is always going to oppose the direction of motion. So again, as usual, we're going to usually with these friction problems, we want to find the normal force first, even though we can't solve for it explicitly. So to find the normal force first, sum the forces in the y direction. And so let's see, we have our 200 pounds down. And then we're going to have our normal force up. Then we want the y component of this 140, which is going to be 140. What's that going to be? Sine 35 degrees. And we want the y component of P. P sine 20 degrees, all set equal to 0. And so it's going to be, so if we solve for the normal force, it's going to be 119 minus 0.342 P. In other words, sine of 20 degrees is 0.342. And then 140 sine 135 is 119. That gives us that. So now sum the forces in the x direction. And so again, let's see, we're going to have in the x direction. We'll take the x component of this one. And then we're going to have our friction force moving to the right. Let's see, by the way, this is going to be negative, isn't it? That one's going to be negative. And then our friction force is going to go in the positive direction. Then we want our x component of this thing here, that 140. And set that all equal to 0. And so over here, let's see, that's going to be the cosine of 20 degrees is 0.94. So 0.94 P. Now for our friction force is going to be mu times n. N was from up here. That's going to be our friction force, mu times n. And then just calculate this. That's 114.68. Then we're just going to carry down to the next step. Multiply these out. And multiply these out. And bring this down. And put these together. And 6, solve for P. And that's the force required to get the block moving to the left. So just some basic things to remember for these fundamental friction problems. Again, for friction problem, they can get more complicated later on, but we deal with these very basic ones. Remember several things. Usually you want to find a normal force first. Even if you can't find it explicitly, like, in these a couple of these problems, we couldn't find it explicitly, but we could find it in terms of another force. So solve for it, even though if there's another unknown there. So you'll usually find it first. And then number 2, the friction force is always going to be mu times the normal force. And then 3, the friction force will always oppose the motion. In other words, if the force is such that the block, wants to move, say, to the left, or the sum of the force ends up wanting to move to the left, the friction force will be going in the opposite direction, to the right. Or if the resultant of all the forces want to move it to the right, want to move, say, your block or whatever object you have to the right, then the friction force will always be pointed to the left. It's going to always be opposite of how the block is moving, or opposite to the direction that the block wants to move. So again, like I said, if it's trying to be pulled this way, or the resultant force is this direction, the friction force will be in that direction. If the resultant force is in this direction, the friction force will be in that direction.